Work on the problem. It says a compound containing 5.93% hydrogen and 94.07% oxygen has a molar mass of 34.01 grams per mole. Determine the empirical formula and molecular formula for this compound. So we're going to learn what we want, which is empirical and the molecular formula. Okay? So we need to know some things like how to solve it. So if we're looking for the empirical formula and we're looking for the molecular, let's look at empirical first. What do you need to know as far as formulas and how to solve it? Okay, we can start off with a percent, and then what else?
Grams.
And then what?
Moles.
Okay, then what?
Divide by the smallest.
Very good. Okay, so there's our little formula. And what if we don't have a percent?
Go to grams.
Just start with grams, right? Okay, and then if we're going to go from percent to grams, what do? Assume 100 grams. So for example, if it's 55%, it would go to 55 grams. And 45%, because those make up 100, and it'll be 45 grams. So there's a little snippet of how to do that. Molecular formulas. If we're solving for molecular formulas, what two pieces of information do we need? We should know the molar mass and what else? The molar mass and the empirical. And if you know both of those, what do you need to do in order to solve?
Divide.
Well, you're going to divide something. What are you going to divide, though? We would have to need a multiplier, right? So in order to get that, it's all about me. So it'll be molecular over the what? Empirical. And it's molar masses, right? And when we do that, we should get a number, and that number is called the multiplier for our benefit. And that means that when we go up here to our little tic-tac-toe side of molecular formula versus empirical formula, you'll basically know how to multiply out the empirical formula to get to the molecular formula. Because remember, the empirical is just the what? Brick, and the molecular is the... Okay, so there's our two pieces of information that we're going to need to know. And so let's start off. First off, what are we going to solve for first, molecular or empirical? Why? Because you needed to even solve for this, right? So let's go back. Now, my numbers are in percentages, so we're going to start with percentages. That's good. So I got 5.93% of hydrogen. And then I've got what? 94.07% oxygen. So in order to solve from percentages to grams, we're going to assume what? They're 100, so this is going to turn into what? 5.93 grams of hydrogen and 94.07 grams of oxygen. Now, for our purposes right now, I'm going to just start with hydrogen and work all the way to the end, and then we're going to come back and work oxygen all the way to the end. So in order to go from grams to, we're going to go from grams to what? Next, moles, right? Okay, so if we're going to go to moles, we're going to have to use old school. Let's go back and look at that. GMA. So we're at grams, we're going to go to moles. So if moles is going to be on top, what will be on bottom? The grams of hydrogen. Now, we know one goes with mole because it's a mole-gram ratio and they're opposite, or that's the conversion factor you need. Now we're going to look at the grams. Where do we get grams from? You're at a table. Very good. So it's 1.01, right? All right, somebody do the math there and get me an answer right here. While I'm doing that, let's go to the rest of you guys. I'll have 1 mole of oxygen over 16 grams of oxygen. Those cancel, those cancel, those cancel, and those cancel. You're left with how many moles of hydrogen? Anybody? Okay, so while y'all are still solving that, I'm going to go ahead and finish this section up, which is going to be moles of oxygen. So what's our answer? 5.93 divided by 1.01. 5.90? Okay. She's got that. Check it, somebody else. Now somebody else go and try 94.07 divided by 16. She's got 6. Even 6?
It's like 5.8.
5.87. So let's put that down. And this is 5.90. We're good with that? So now what we're going to do is we're going to look at them. What is the smallest of the two? 5.87. So let's divide by 5.87. Divide by 5.87. 5.9 divided by 5.87 is pretty much going to be what? 1, right? And 5.87 divided by 5.87 is 1. So you have a 1-to-1 ratio. So if you look at the hydrogen, it's going to be 1, and oxygen is going to be 1. So we already can see that that is a hydroxide, right? So it would look like HO, and you would not have to put the numbers in there. So now let's just figure out like a little tic-tac-toe board. And the way I do that is we're going to go to that side of the board. So the tic-tac-toe, and we're going to look at the empirical first because it's the small, the molecular second, because now we know what we've solved for. We've solved for MOH here. And we know that the end molar mass, according to our problem, is 34.01, right? Now, we don't know if this, that's grams per mole. We don't know if this 34.01 goes with the empirical formula of molecular at this point in time. So we're going to have to figure out the empirical molar mass. So these are the molar masses. These are the formulas. So the molar mass of this, we obviously can say MM for this would be OH. 16 and 1.01 is equal to 17.01. Is that right? Yes? Everybody good with that so far?
Yes.
So 17.01 grams per mole will go here. Are they the same or different?
Yeah.
They're different. So that shows me now I need to go into my actual formula in order to solve to find out what the molecular formula is going to be. So we're going to put what we know in here now. We know it's different. So we're going to go in here and use our little formula, which is M molecular over empirical. We're talking about molar mass weights, or masses. So molecular, which is going to be 34.01, divided by empirical, which is 17.01, is going to roughly give you a multiplier of what? It's going to give you a multiplier of 2. So we go up here and we multiply everything up here by 2. So we would have O2H2. Another way you could write that, because I see what it is now, it could look like this right here, H2O2. Okay, so the question going back over here, it says, determine the empirical formula and the molecular formula for the compound. So the empirical formula was easy because we figured out it was OH by solving for the empirical formula. We then went over here to the left or to the right of the board, and we pulled in what we solved for originally, which is the empirical formula. Then we found out the molar mass of the empirical formula. Then we compared that to the molar mass that we were given in the problem. When you compare that to it, you know that they're not the same. So then you plug it into the equation, which is the molecular divided by the empirical molar masses, and then you end up with a multiplier of 2. That, again, is just Miss Smith's little multiplier name. It means that you're going to multiply it by everything from the empirical formula to get to your molecular formula. Okay? Good? All right. Stop.